Okay, so we've got some cycle notation. Cycle notation is you normally write sigma for a permutation, and sigma equals A1, A2, dot dot dot, AR, let's say. So there's the first component of the cycle. AR plus 1, AS, and so on to let's say T plus 1, dot dot dot, AN. And of course, N equal, that N is the same N as in Sn here. So all these symbols are distinct. Okay? You might miss out ones. Remember that we had a one cycle. A one cycle is kind of stupid because it's a fixed point of the permutation. So the length of sigma, I guess that I put quotes there, length of sigma may be less than n. Can't be bigger than that because you've only got n symbols to choose from. So that's that. Let's just have a look at some of the ways of describing these cycles. So just thinking about this, the representation, the cycle representation, is unique, except for one or two things. You can write them in any order for the order of the cycle, except for the order, the cycles of the cycles, and cyclic permutations of the cycles themselves. Cycles themselves. Oops. Themselves. So for example, the permutation 1, 3, 4, 2, 5, 6, 7, let's say, that equals, well, I can write down, instead of 1, 3, 4, I can write down 3, 4, 1, because look, 3 goes to 4, 4 goes to 1, 1 goes back to 3, 3 goes to 4, 4 goes to 1, 1 goes back to 3, times, instead of 2, 5, 6, 7, I can start anywhere, I can start at the 7. 7, 2, 5, 6, and indeed I can write them down in any order. So I can cyclically permute the elements within a cycle, and I can also write the cycles themselves in any order. Okay. Yeah. Okay. Well, that's the place to start, and we've also got another notation which is called the shape. I'll put that in scare quotes, of the cycle. Well, you normally write that with a multiplicative notation, and you normally write it down as something like this: 1 to the alpha 1, 2 to the alpha 2, 3 to the alpha 3, all the way up to n to the alpha n, n to the alpha n. So what that means is that we've got a total of alpha 1 cycles, alpha 2 cycles, alpha 3 cycles, and so on. So I'll give you an example. If you have 1, 2, 3, 4, 5, 6, 8, 9, 10, that's going to be, as a member of S10, let's say, well, look, we've got 1, 2, 3, 4, 5, 6, there's 7 missing. So it's 1 to the power 1 because we've got a single 1 cycle. 2 squared, 3 to the 1. And that equals the shape of this element here of x. Okay, I'm going to stop there.